This video, we're going to talk about implicit differentiation. What you need to do is rethink how you take derivatives. If you have y equal x squared and you're asked to find dy over dx, well, the regular way you would do it is you would say that the derivative of y is dy dx, and the derivative of the right side is 2x. We're going to think about this a little bit differently now. Just like the derivative of x is 1, the derivative of y is 1. And the derivative of x squared is 2x. But now, every time you take a derivative, you have to add on a differential. At least that's my opinion. Now, y is in terms of y, and we are taking the derivative with respect to x. The derivative of x squared is 2x. This here is in terms of x, and we're taking the derivative with respect to x. That's going to cancel out like to 1. So dy dx is equal to 2x, just like normal. Nothing different there. At least the answer wasn't different. If you were asked to find dy over dt, that means you're taking the derivative with respect to t. If you learned that y equals t cubed, the derivative of y is 1. This is in terms of y with respect to t. The right side, derivative is 3t squared. This is in terms of t, and you're taking a derivative with respect to t. That kind of vanishes. So you have dy dt is equal to 3t squared. Probably what you would have gotten even before I wrote it down, before we talked about implicit differentiation. Now I want you to find dy dx for this function. For x cubed plus 2y squared equals 7. The derivative of x cubed is 3x squared. It is over times d over d for now. It's in terms of x, and we are taking the derivative with respect to x, plus the derivative of our 2y squared is 4y. It is times the differential. This is in terms of y, and we're taking the derivative with respect to x. And the derivative of a constant is 0. You want to add on or multiply by dy dx or dx dx, that's fine. So this is really 1. So you have 3x squared plus 4y times what you want to solve for equals 0. So let's figure out what that term is first, like always. Bring that to the other side, and you get negative 3x squared. Now we divide both sides by 4y, just because we only want to have dy dx. Do the same to the other side, and we are done. Okay, that is the answer to that problem. Suppose you're asked to find dy dx. Now that tells you immediately you're finding the derivative with respect to x. Find dy dx for this function. 5x squared y minus 3y to the 4th equals xy cubed. Now the thing here is you have a product. you have 5x squared times y. Here you have x times y cubed. We're going to have to use the product rule. The derivative of the first is 10x. It is clearly in terms of x, and as I mentioned, we're taking a derivative with respect to x. That's the derivative of the first times the second. Why don't I put dy dx or dx dx? Simple. I didn't take the derivative this time. Plus, still in a product rule, the first function, 5x squared, times the derivative of y, which is 1. It's in terms of y, and we're taking the derivative with respect to x. Okay. Just moved it over to give me some more space. Equals. The derivative of x is 1. It's in terms of x with respect to x times the second function plus the first times the derivative of the second function, which is 3y squared. Y cubed is clearly in terms of y with respect to x. Let's clean this up a little bit. This is pretty much 1. 10x times y is 10xy plus 5x squared times 1 is 5x squared times dy dx equals, this is 1 times y cubed plus x times 3y squared is 3x y squared dy dx. These two terms have dy dx. Let's bring them all to the left side. So that means this is going to go to the right side and that to the left. So 5. And we know that everything on the left side will have a dy dx by design. So we can factor it out. So we have positive 5x squared. And when we bring these over, it'll become negative 3y squared. And the right side has y cubed, and we bring over the negative 10xy. Okay. So at this point, what we do next is erase this. And it's natural. What we do next is common. We divide by the number of dy dx's we have. We divide by this number on both sides. This cancels out to 1, so you have dy dx is equal to y cubed minus 10xy all over 5x squared minus 3xy squared. And there is your answer. Okay. Suppose you wanted to find the derivative of x squared plus y squared equals 5. Well, the first thing is, you don't really need calculus to do this. You can just use elementary algebra, or geometry. This here is a circle. Okay? It's a circle centered at the origin. If this point here is x comma y, then that's because that's x comma y, because this piece is x and this piece is y. So the slope of this line, the slope of that line is y over x. The change in y, which is this, divided by the change in x, which is that. It's y over x. Okay, so then the slope of this line is perpendicular. So you flip over the y over x, and you change the sign. That is, dy dx is just going to be negative x over y. By the way, I should have said find dy dx. Okay, so we know the answer, but let's use calculus. The derivative of x squared is 2x. X squared is in terms of x, and we're taking the derivative with respect to x, plus y squared, the derivative is 2y. It's in terms of y, and we're taking the derivative with respect to x, and the derivative of a constant is 0. And that's also 1. So we want to solve for this term first. So let's bring that over. So 2y times dy dx is negative 2x. Then we divide by the 2y, and the magic happens. We just left with dy dx. The 2's cancel, and we get negative x over y, which I said would be the answer by using elementary geometry. And for whatever it's worth, when I was given this problem in Calc 1 to find the derivative, I did this geometric proof, and my teacher wasn't happy because I was supposed to use calculus. But he never said that, so he had to give me full credit. Now, suppose you were asked to find dy dt for x cubed minus 4y squared equals to y. Okay, so we take the derivative of that, which is 3x squared. It's in terms of x, and ooh, be careful. It says take the derivative with respect to t, minus that derivative, which is 8y. It's in terms of y with respect to t, equals the derivative of y is 1. It was in terms of y with respect to t. So we have 3 terms. 2 of them have dy dt, which we were asked to find. So let's bring that over. So the left side is 3x squared dx dt, and the right hand side, by design, we're going to have dy dt factored out. We have one of them, and we're bringing over negative 8y as plus 8y. Okay, so now we're done. We divide both sides by 1 plus 8y, and we have dy dt. Dy dt is equal to 3x squared over 1 plus 8y, and we'll just say times dx dt. Notice that this didn't cancel out. If it would have said find dy dx, then this would be dx dx, and it would vanish. And that would say dy dx. Let's try something slightly different. Find dy dx at the point 2, 1 for this function. X cubed plus y cubed equals 9. Now, but basically, we have some curve, and the point 2, 1, they're asking for the slope of that tangent line. The first thing I would do, just to get out of doing this problem on a test is I would make sure that this here is a point on the curve. And yeah, 2 cubed plus 1 cubed, that's 8 plus 1, yeah, it's 9. Okay, but I would check that. Okay, and if it weren't on the curve and you do the problem, then you can be marked wrong if your teacher didn't do it on purpose or didn't catch it. Okay, so it says to find the derivative with respect to x. So this is 3x squared, and let's grow up a little bit. If it's in terms of x and we're taking a derivative with respect to x, the dx over dx vanishes. So I won't write it anymore. Plus, the derivative of that is 3y squared. It's in terms of y. We're taking a derivative with respect to x. And the derivative of 9 is 0. So this is the only term that has dy dx. So I'm going to bring this to the other side. So positive 3y squared dy dx is equal to negative 3x squared. We divide by how many dy dx's we have, namely 3y squared of them. And we just end up with dy dx, and this is equal to negative x squared over y squared. Now, they want, so this here is a function of x and y. I know it is. I know it is. Because I see x and y's there. So they want dy dx at the point 2, 1. So it's negative 2 squared over 1 squared, which is negative 4 over 1, which is negative 4. Okay, so basically, we just found the derivative the way we've been doing for this whole video, and then I plug in 2 for x and 1 for y. Suppose you had x cubed y plus 3y squared, all squared, equals to x plus y, and their instructions are to find dy dx. Okay, this is a power rule function. Keep the inside the same, bring down the power, make the new power 1 less. Since the power is 1, you don't have to write it. Okay, times the derivative of what's inside. Okay, this here is a product, so it's the derivative of the first. Since it's in terms of x and we're taking a derivative with respect to x, nothing has to be multiplied, times the second function, plus the first function times the derivative of y, which is 1, which you don't have to multiply by. It's in terms of y with respect to x. That is the derivative of x cubed y, plus the derivative of 3y squared is 6y. It's in terms of y with respect to x. And this is equal to the derivative of x is 1 plus the derivative of y is 1 times dy dx. Okay. Let us clean this up. This times this is, well, you have 2 times 3 is 6. So you have x cubed y plus 3y squared. I just wrote this down, times x squared y. Plus this times that. Well, that's going to be, I'll say 2x cubed. So I said the 2, I said the x cubed. Now I have to say this big mess, x cubed y plus 3y squared times dy dx. Dy dx. And I have plus, Now I have to multiply this by this. Well, 2 times 6 is 12y times x cubed y plus 3y squared dy dx. And this is equal to 1 plus dy dx. Didn't realize what a mess this was going to be. Okay. Actually, maybe it's not so bad. So these are the terms. You have this term, and all the other terms have dy dx. This has dy dx. This has dy dx. Oops. And this has dy dx, but the one does not. How about we bring the dy dx's to the left side? So on the left side, we already have 2x cubed times x cubed y plus 3y squared of them, as well as the 12y times x cubed y plus 3y squared. And then when we bring this over, we're going to have minus 1. And all of this is dy dx. And this is the left side. The right side is going to have this 1 minus this when we bring it over. 6 times x cubed y plus 3y squared times x squared y. Okay, so the answer is very clear now. Dy dx, I'm just going to divide both sides by this mess. It's going to equal the right side, 1 minus 6 times, I'm going to say x squared y first, times x cubed y plus 3y squared. And all of this is over this mess. Now, I just happen to notice that this and this are the same. I wonder if that's not a mistake or not. But how many of them do I have? I have 2x cubed plus 12y of them. Them being x cubed y plus 3y squared. Don't forget to take away the 1. Minus some silly error like always. There's our answer. Let us try another one. Sometimes you have to be a little bit clever. If you have this equal this, well, you can use I meant to say x squared plus y squared. You can actually just go and hack at it, keep the x plus y the same, use the power rule. Bring down the 2, make the new power 1 less, which you don't need to write, then multiply by the derivative of what's in there, which would be 1 plus dy dx. And on the right side, you have 2x plus 2y times dy dx. Now, if you distribute this times 1, you'll just have 2 times x plus y plus 2 times x plus y dy dx. The instruction is to find dy dx. And you'll have the right side doesn't really change. Dy over dx. Now, these two terms have dy dx's. How about I bring them to the left side? Now, this is really 2x plus 2y, and when I bring these over, becomes minus 2y dy dx's. And I still have the 2x, and I bring this over as minus 2 times x plus y. So this cancels. You have 2x dy dx equals, now this is 2x minus 2x, so that cancels, minus 2y. So the right side is just minus 2y. if you divide by 2x on both sides, you're done. dy dx is, the 2's cancel, negative y over x. But this was much harder than we needed to make it, because if you have x plus y squared is equal to x squared plus y squared, you should simplify first. If you FOIL this out, you'll get x squared plus 2xy plus y squared equals x squared plus y squared. This cancels. This cancels. So you have 2xy equals 0. In fact, you can divide by the 2, but let's not. So we have a product here. The derivative of the first is 2 times the second plus the first times the derivative of the second, which is dy dx, equals the derivative of the right side, which is 0. This has dy dx, this doesn't. So we bring it to the other side. So 2x dy dx is negative 2y. Divide by how many dy's you have, which is 2x of them, and you learn that dy dx is equal to, oh, the 2's really do cancel, negative y over x. In my opinion, this was a lot quicker. So here's the problem. This time, don't want you to find dy dx. I want you to find the second derivative for x squared plus y squared equals x. Okay. So first we find the first derivative. First we find dy dx, and then we take the derivative of that with respect to x. So you have 2x plus 2y dy dx equals 1. Bring this to the other side, and you have positive 2y dy dx is equal to 1 minus 2x. Divide by 2y, and now you know that dy dx is equal to 1 minus 2x over 2y. So now it's a brand new problem. It's a brand new problem. Find the derivative, take the derivative, so, take the derivative of both sides with respect to x. So the left side would just be the second derivative, equals. Quotient rule. The derivative of the top is minus 2 times the bottom minus the top times the derivative of the bottom, which is 2 dy dx, all over the bottom squared, which is 4y squared. So let's just clean this up a little bit. We have that the second derivative with respect to x is negative 4y minus 2 dy dx's minus 4x dy dx. Well, okay. So the good thing here is only the left side has the second derivative, what they asked us to find. Let me just write it a little bit differently. Minus 2. Let me think. Okay. 4x minus 2. Minus a minus becomes 4x minus 2. That is how many dy dx's you have. This should not get you full credit. What you should do is, we found dy dx. We should use that information. We found that dy dx was 1 minus 2x over 2y. Okay? So, we should say 1 minus 2x over 2y. And that is the second derivative in terms of x and y, not in terms of x's, y's, and dy dx's. Now I only see x's and y's. And that's how you should write the answer. This completes the video for implicit differentiation.